And we are a go. Good morning and welcome to this webinar on trends and solutions in Edge AI and TinyML, brought to you by Tata Elxsi and Syntiant thought leaders in this space. Right? Before we start, let me do a quick request. Let me make a quick request to our viewers. Can you please send in a quick question in the Q&A window so we know that we're receiving your questions? So when we have the segment Q&A segment at the end of the panel discussion, we will be able to see your questions. Right? Thank you. So let me start by introducing our panelists. We have Dr. Malik Mathuri. He's the Vice President of Business Development and Product Management of Sentient. Malik has been one of the first few early members of the leadership team of Sentient. 30 years in the semicon business. He is a domain expert in AI. And Malik, before I say anything else, let me say congratulations for the second CS Innovation Award that you received this year for the NDP 120.
Thank you, Bhaskar. Yeah, appreciate it, and we are really honored to be in that august company of people who have been, or companies who've been able to get that award. We did that last year as well. The Consumer Electronics Show, as you know, but this year was, we had to do it virtually, but we received it was nice to have that. But yeah, it's been a great run this whole 2020, though it's been unfortunate time for most people. We've been fortunate. Sentient has actually had been able to get not just the award, but we also announced that we shipped more than 10 million of our first generation product in the market already. So we have made our presence felt in the market this year. So and thank you. Yeah, so it's been interesting. I'm looking forward to this talk.
So are we. So here's fingers crossed for maybe a hat trick on the Innovation Awards. Who knows next year, right? You're most welcome. Let me introduce you to Dr. Milan Gandhi. Milan is the Vice President of the Systems Business Unit and Smart Homes at Tata Elxsi. Many years in the company, and he and his team has been working on very exciting projects across the world. And Milan, I'm so glad you're on the panel, and I'm looking forward to a very interesting conversation.
A pleasure to be here with the entire panel, Malik, Naren, and yourself, Bhaskar. Just this morning, we announced our partnership with Sentient, and very excited in terms of what this partnership can do for for people who want to introduce products using a voice interface. Naren, you want to introduce yourself? I think.
Hey, hi. So thank you very much for this opportunity. And I think from a design point of view, especially when, I sort of claim to represent the end consumers and end users of all the technology development and products that we're talking about. It's a great honor to be at this cutting edge where we're actually talking about products that will revolutionize how people live their lives and what new things will happen in their homes and in the world around them. So thank you very much for giving me this opportunity. And yes, I'm with Tata Elxsi for the last 23 years, and I look at design.
Thank you.
Yes, so Malik, while we wait for Bhaskar to come back, can I request you to give a very quick introduction to Sentient?
Yes, definitely. Yeah, I know I did not. Hi, Bhaskar, welcome back. I think you had a small issue with the connection.
Sorry about that.
So no problem. So I know with all these days, interesting times we are living. So yeah, we have a company which has been founded in 2017. Sentient was founded in 2017 with at that time our lead investor being Intel Capital. And the founders, we have 4 founders, and we got together to start the company as an idea concept of, at least one of our CEO was sitting with his son, and he was just using the touch screen, and then later on started just talking to it, so he's like, yeah, this is really where we want to go. And, thinking of, we're all been in the semiconductor industry for a while. So we thought, oh, we should start a semiconductor company. And at those, back in those days, everybody was, what are you doing? How would you start a company in this? But interestingly enough, in the last few years, we've seen, hundreds of AI chip companies come into being. We've been fortunate. We had not only great investors, we have a great team. We have about 70 employees. right now. In the last 3 years, as I said earlier, we launched 2 products already in the market in production. The first generation one has already shipped more than 10 million chips. Our team is very experienced. Median experience in the company is more than 20 years. As I said, we've been very quick to market. We first built this first product was in 2018. Production in 2019, and last year, 2020, our C round was completed with lead investors being Microsoft Ventures. So we have now not only Intel, we have Microsoft, we have Amazon Alexa Fund, we have Bosch, and Atlantic Bridge joined us in the C round last year, and Applied Ventures. So we have really a good team of large number, great investors with a lot of experience in the industry. And we have located in Irvine in Southern California. We have offices in India, Taiwan, China, UK, and Denmark. So that's in a nutshell. Thank you.
So Milan, may I request you to give a quick introduction to Tata Elxsi?
Sure. So thanks so much, Bhaskar. And Elxsi is a member of the Tata Group, India's largest industrial conglomerate. The company focuses on product engineering services, but the unique feature of the company is that it focuses not just on technology, but also on design. At more than 800 plus designers, we are probably South Asia's largest product design consultancy. And we believe that this sort of partnership between design and technology is what makes us a unique company. The company focuses on 4 verticals: automotive, broadcast, medical, and smart home. What this knowledge of these verticals does, so it's our belief, and we'll talk a little bit more about this today, is that the challenge that most product designers face is that they have to make sure that AI is not just a shiny new bauble, right? It's something that adds genuine value to their to their customers, and that is possible only if the use case that AI enables is built with deep domain knowledge, as well as tremendous empathy for users. And this is really the domain-specific customization that we hope to bring to the market along with Sentient. Looking forward, this is a very, very exciting times. The company has development centers in Bangalore, Pune, Chennai, Trivandrum, and Mumbai in southern India. And then also presence in North America, Europe, Japan, as well as China and Singapore. Yeah, Bhaskar?
Thanks so much, Milan. So AI at the edge, ML, TinyML, these are no longer buzzwords, right? These are very much realities now, right? So we have second generation, third generation products and technologies in these areas. So very, very exciting times, right? So my first question to you, Malik, is how is AI at the edge revolutionizing technology products, and how is it enabling new and interesting use cases?
Thanks, Bhaskar. So, we call it, as I said earlier, when we started the company, we're thinking about voice, but more we are seeing the intelligence. We're seeing it. We call it the intelligence of things now. We've heard of IoT, which is which is a broad category, but we are seeing a real renaissance in these technologies entering into these devices, right? Like machines, automobiles, and these things, which I said we've been using that, which we use in our daily life, right? At home or office, factories. These are becoming more intelligent by adding neural networks, or they are intelligence of things, what I call, where basically that intelligence has been increasing in these devices over time, because they simplify our life or enrich our users' lives by being intuitive, perceptive, so that you can take reasonable actions. So these devices can take reasonable actions on our behalf. For example, your smartphone is a very great example, where you have set an alarm, and you don't have to, you can just talk to your device now. So this revolution is now always the ability of AI to solve these problems more effectively than in the past. That's the revolution we are seeing. And one of the reasons why there's this resurgence or this increase in AI in these edge devices is because the large amounts of data that's being generated, right? So as the data has been generated and collected, more efficient algorithms have been developed in the last few years. And because of the compute increase in the compute in the cloud, so we've been able to train more with the data that we have been available, and the pipeline that is, that researchers have developed more and more neural networks, more modeling techniques. Now, that combined with this, also what I mentioned in the last few years, the number of companies like ours, Sentient, has come up, but where you can pull in that intelligence into the edge device in silicon. So a combination of silicon, data, and the algorithms, so the pipeline, is this revolution. That's the combination. Whoever has all of these magic components can put together a very good solution. And we have seen that. We are seeing that in lots of industries, and Sentient itself, our first generation product, has so much acceptance. We've been pulled into different sectors. We've been working with automobile companies and manufacturing, health, consumer, obviously, consumer and retail. But let's look at, for example, just as an example of automobile as a revolution of technology, where products are, I was just at my car dealer recently, and he was asking, I was just trying to ascertain the tire pressure monitoring, and the TPMS system there has a battery, and that has to be replaced very frequently because it's got this intelligence, sort of intelligence, but they still have to measure it. But that's an example of place where we start seeing examples like TinyML showing up, very, very, very low power, like Sentient's device, that could measure. And not only can it help you in the tire pressure monitor, but also on the road while driving, adjusting the pressure as well as the information back to the user. So that's just an example. Then we are seeing that, and as I said, point of service in retail, and hands-free for being hands-free. We'll talk more in the next few minutes, but those are just generally, we're seeing health monitoring, agriculture and fisheries, manufacturing, a lot of different applications.
Yes, so maybe I will give my point of view from the other side, from the side of the consumer. See, in the consumer's mind, they like to, quickly fall down to the simplest level of any device or any technology or any understanding that they have. So, which means, like Malik was saying, if a person's phone is intelligent, then very quickly he's going to assume that the microwave and the washing machine and the oven, all of them can be intelligent, can be smart. And the other aspect of smartness that is changing very quickly, and which will actually lead to the revolution that we're talking about, that a smart device is no longer just a connected device. I mean, you have your, let's say, televisions and other products that are connected to the internet, but that will no longer be constituted as a smart device. A smart device would be something or somebody or a device that can think for itself in its own location, in its own, let's say, geometry. And any device that has to sort of reach out to the cloud and talk to some other intelligent system and come back with an answer will no longer be thought as a smart device. And that's where this entire TinyML and Edge AI really makes a huge step forward, because in the perception of a consumer, if my device is smart on its own, then that's the true smart. And that's where we'll see a lot of demand coming. And what I expect happening is the market will start pulling for these kind of features in their products around them. And that's what would then push the industry to really deliver that level of experiences for the products. So, yeah, back to you. So, Milan, maybe you could just add some of your points on this. Yeah, Bhaskar, back to you.
Yeah, I'm back. I'm sorry, I've been having terrible connection. So please bear with me. But those are fascinating inputs. Malik, from you, in intelligence of things, IoT. It's a new definition, and I love the example of the car OEM dealer. You obviously have the name of the dealer, so I think we should go to market together, Tata Elxsi and Syntiant, and make sure that OEM has TinyML in their TPMS system. Yeah. And then, of course, what defines smartness? Very, very interesting. Yeah. So my next question is actually to you, to Malik, is that we are seeing a lot of interest and momentum in voice interface technology, especially given the current pandemic situation, and especially in consumer electronics, right? But do you also see interesting use cases beyond consumer electronics with voice? And my second part of this question is, what are the challenges and complexities in deploying, AI-enabled voice solutions?
Yeah, thanks, Bhaskar, and I'm sorry about your troubles over there. Anyway, so yes, this pandemic situation has, there's a lot of different use cases in different industries. Obviously, consumer electronics is, personal device, but in a public setting, we're seeing, voice interface is actually quite effective, useful for hands-free operation. Let's take automobile, for example, or you're outside in a traveling. Right? Hands-free control, for example, is very important for an automobile, right? Even not only for in this pandemic, but generally hands-free control where you're driving safety, driver safety, for vehicle entertainment or climate control, or vehicle access, even to enter the automobile. Or you go to a shopping center, retail, you want, at the point of service, if you can be hands-free, point of sale, I mean, shopping can be a quicker process, not only quicker, but also more effective with voice. So I see that as, being a more touchless use cases everywhere. We are seeing that even in elevators, where you don't have to touch the buttons on the elevator. So I think the factory floor as well, we're seeing robots being controlled by voice. Doctors in operation or healthcare, are looking at professionals there are looking at operating equipment with voice rather than because for one, they might, hands might not be free. So I think access control with voice and other in addition to all of this, including if you want to enter a building combined with voice, a face and voice, biometrics are very useful. So we're seeing a lot of these kind of use cases in with voice-based control. We also see certain, even mobile phones, mobile devices. Obviously, now voice interface is really enabling a large number of people, who do not have access to internet previously to access it. I mean, if you think of it, voice is a much more natural interface, and literacy rates are not uniform across the world. So so enabling voice-based interface to a mobile device is ubiquitous. We're seeing that with Google, with their Google Voice Assistant. We are seeing that across now other carriers also. They're all adding their own voice interface to these devices. So we see this voice enabling a lot of people to enter into the internet age. So that's what I think about this.
Yeah.
Thank you.
No, thank you. Very interesting use cases. May I take a question to you, Milan, to have your thoughts on this? How do you see voice interface technology influencing other industries apart from consumer electronics?
Yes, I think Malik has painted, a very broad picture, a very broad canvas. Let me just pick a couple of examples and go in a little bit deeper. I think automotive, Malik mentioned, and we definitely see infotainment as a major driver for voice interfaces. The dashboard, I think, I've always recognized that the dashboard is a major source of distraction for the driver, right? As a driver, you really want to keep your eyes on the road all the time. Seeking information on the dashboard, switching radio channels, picking music, etc. are all things that are taking your eyes off the road. The automotive industry did try to respond to that by moving controls to the steering wheel, and that does reduce distraction somewhat. But still, it does require you to take your eyes off the road for a little bit. So I think, this is an absolutely natural sort of application for voice, and we see that coming in, very, very strongly. We think that this will be more or less the default sort of mode that you would interact with your infotainment system in no more than 2 or 3 years. On the other hand, in home appliances, we are already seeing voice, right? But the way we are seeing voice today is mostly in push-to-talk remotes, right? Whether it's an Alexa Fire remote or whether it's an Apple TV remote, a Siri remote. Most of these remotes have a button that you push, and then you can say something, and then your TV sort of responds. But that's a somewhat unnatural way, right? And given that a lot of these appliances are pretty expensive and are always plugged in, so you don't have some of the BOM constraints as well as power constraints that you're facing. So at least my personal belief is that the time is right for far field voice, where you're able to converse with your appliance up to 6 meters. That kind of sort of far field voice applications will become commonplace in home appliances. Today, it's mostly TV, but I personally believe that air conditioners, room heaters, air purifiers also sort of naturally sort of are designed for voice. Yes, so that's really, just my perspective on where voice is going. Bhaskar?
So thanks so much, Milan. And I'm sorry, I don't know whether you can hear me. Am I audible?
Yes.
No, I shot my video, so I'm hoping you're able to hear me. Yeah. Are you? All right. Thank you.
Yeah,
Thank you. So sorry for that. So Milan, very, very interesting. Far field voice application. Those are very, very interesting. Yeah, very interesting areas. My next question is actually to Naren, and it goes: are we witnessing major changes in the way, and can you share some insights on the design of the UI?
Yeah, hi. So, Milan painted this world where, you can talk to devices around you. But imagine if you don't know which devices can actually listen and which cannot. Then as a consumer, you don't want to look dumb in front of your friends where you're talking to a toaster who is not smart, right? So what is going to happen is there's going to be a complete new semantics or new language of design that is going to come on the physical side of the product, so that you will know very naturally or very clearly that this is a device that is smart, this is a device that can understand voice instructions, and also it will direct you in terms of where to look and speak. Because as a person, as a human, you tend to look at the person that you're talking to. So you'll start looking at the device that you're talking to, and then it suddenly means that the device has to acknowledge that you're looking at him. The device has to acknowledge that you're speaking to him, right? And so this automatically means that the way the products are designed, the way it shows that it is accepting that kind of input is seen in its design, whether it's the lights that come up or maybe something else, right? So that is one aspect, which is the physical design of any of the products. The second, and I think a slightly more important part, is the design of the voice interface itself. See, one of the aspects of voice is, as I guess Malik and Dr. Milan will agree, that if I start talking sophisticated English as like a normal person, it takes a lot of compute power to really understand what I'm saying, and then even more compute power to really understand the nuances of what my meaning is, right? And which will make it really hard for the device to really correspond and respond to my instructions in the correct manner. So then if at this, in the near short term, if I'm not able to really increase drastically the compute power of a device, can I do something so that the people actually start changing the way they talk to devices, so that it becomes easier for the device to understand, and it is natural or is expected for a human to sort of talk differently when talking to a device. I'll give a simple example of how to sort of get this change in behavior of a person for voice interface. So for example, if the voice that is responding back to you from the device or from the appliance, if that is very sophisticated, if that is very humane, if that feels like a human person, the consumer is naturally going to respond in a human level of sophistication and expect the the device behind the voice to be as intelligent as the voice, right? So the voice sort of is a proxy for the intelligence of the device. On the other hand, if the voice sounds mechanical, sounds a bit robotic, then a human will naturally speak softly, maybe speak haltingly, maybe give very precise instructions, and that will make it easier for the device to understand what's happening, right? So just by changing how the voice sounds from the device, you can actually impact the behavior of the people using it, and then make it easier for everybody to sort of have a good relationship with the product. Because we have to remember one thing, that in today's world, people don't give too many chances for a device to sort of, they don't want to learn, they don't want to change too much about the way they are, and they expect the technology to catch up with them. But it's not that easy for the technology to catch up with human expectations, right? And if the human does not have enough of patience to really give my poor little microwave one more chance, then we have to sort of design the entire system such that the microwave has a chance to succeed and build a relationship with the human. The second point, and I'm just sort of continuing on this, the second example of what you could do from a voice interface design that will again help change and make this entire relationship succeed is to actually create this relationship. Now we talk about wake words, and the many companies, whether it's Alexa or Siri, the reason why they use a single wake word is obviously they want to create a single brand across the world where that word automatically is something that people become used to. But going forward, if I'm able to give my microwave my own name, if I call my microwave Murphy and my neighbors calls their microwave Mickey, then what's going to happen is I'm going to give my poor microwave, poor Mickey, some more leeway in learning. And I'm going to say that, oh, my poor Mickey is just 2 months old in my house, it's still learning to live with me. So I have to instruct it 2 or 3 times before it understands what I say. Right? So the moment I bring in these human emotions into this kind of relationship with my product, I'm giving a better chance for the product to succeed and better patience for the entire relationship to blossom. So those are simple tricks that we can use from a design point of view to really make some allowances for the technology that are needed. So those are some of my points on the physical and the voice interface design.
Thanks so much, Naren. I love the personification that you talked about. I think it's going to be really effective, right? If you give Mickey a name, and thank you so much. So my next question is to you, Malik. We've been seeing a huge surge in the adoption of TinyML, right, for AGI implementation. Would love to hear your comments on that. What's triggering it?
Yeah, thank you again, Bhaskar. So Naren's explanation and of the voice UI and the design of UI is actually very interesting. I mean, just if I may, I'll get to that question in a second. It's one of the reasons why we find it very exciting to work with Tata Elxsi, because of the design aspects and the idea that we can work, across. So we are a technology company, as you know, and we, this collaboration, we're looking forward to that kind of interaction. So let me talk about a little bit about the challenges. I mean, we are a technology company. We see challenges, right? I mean, one of the challenges, as Naren mentioned, is really in the problems, the challenging problem of tackling voice interface. Just as speech itself is one of the more challenging of all the, aspects of how humans interact. In the sense that, it's a very diverse. Vocal tracks are very diverse. Everybody talks with a different accent, different parts of the world. I think it's even more challenging for AI than even image, which is a static image, or you can detect what an object is. But here it's when a human talking, it's have variation in voice, person to person. Even the same person can sound different depending on their mood or time, location, where they are, in a noisy room. You might change your the level of your voice, can be sound, so all of these things, even words, there are many homophones or homonyms among different words. So a machine, and he was saying, my poor microwave sits there and, it's supposed to recognize as well as a human being. That's a pretty challenging problem. And we are now telling all of this to be done in these TinyML devices, which are, tiny machine learning or tiny devices with small amount of neurons. But if you can do it effectively at low power and performance, like what Sentient has been able to do, I think that's where TinyML is starting to take off, and that's what we are seeing now. Why that resurgence or the growth in TinyML. I mean, MCUs have been in the market now for many years. Today, the MCU market or microcontroller unit market in 2020 was about 23 billion units per, this year, last year. We will grow to potentially about 30 billion by 2023. Now, a large portion of this, we believe, and we are seeing that in the market, and in fact, there are a lot of early adopters in this microcontroller unit. It's still in the early adoption stage with them. And we will see probably about 30% of that microcontrollers, which we see everywhere in our day-to-day life. 6-7 billion of those units in the next 5 years will have machine learning or AI built into it, maybe even more. So we are seeing this, this growth because one of the challenges of TinyML, as I was saying, was they are very resource constrained, small power, low power. So if you have to make it small and efficient, and with lots of processing power, because of just like an example of voice, one of the most challenging, again, as I was saying a few minutes ago, it's challenging. It has to be doing a lot of parallel processing to do voice recognition. It's really a speech recognition engine. Though wake word, as Naren was mentioning, is one aspect of voice. Personalization, it could be like the microwave or a TV, for example, would respond differently for different members of the same family. So those are examples of where we are seeing this kind of personalization. You don't want to send all of this data. Privacy is a big factor. So we see TinyML ability to reduce the latency. That means that you don't have to go to the cloud. Like, for example, you had this connection issue. That's an example of where you don't want to lose connectivity, and then suddenly I cannot use my microwave because it doesn't have connection to the internet. So that's robustness, and it has to be fast responding. You say stop, it has to stop. You cannot go to the network and cloud and then come back and say, oh, now he said stop, right? Then my popcorn will be burnt by the time it stops. So that's what we're seeing. We're seeing a lot of this, as I said, high performance engines like Sentient's NDP being embedded inside these devices. And then the tools. There's a lot of consortiums also we're part of. We like Machine Learning Commons, ML Commons, a number of big, large organized companies like Google and Facebook and ARM, and Sentient is part of it, Baidu as well. So around the world, a number of companies are coming together and providing tools and accelerators for machine learning. And I think that's what's driving this adoption of TinyML in the edge. Thanks, Bhaskar.
Yeah, thanks so much. And those numbers are huge, Malik. When you talk about 30% of 30 billion potentially, those are huge numbers. Absolutely. Milan, may I have your thoughts on this, please? On the surging adoption of TinyML?
If you look at TinyML, really, right, to my mind, it is the coming together of two big trends. It's the coming together of IoT, and it's the coming together of AI. Now, what's really driving this, and Malik spoke a little bit from the user perspective. Let me also talk a little bit from the technology perspective, right? I think what's making this this entire TinyML's so common is really the coming together of three key trends: cheap communication links, a proliferation of sensors, and low cost, low power, small compute elements at the edge. The kind of chips that Malik has been talking about, right? The NDP 100, the NDP 200. And I'm saying they're sort of tiny compute engines only in comparison to what is available in the server. So if you go back, let's say 3 or 4 years, a typical AI system would be architected primarily just haul everything back to the cloud, let the cloud do what it needs to do and come back. And then, as Malik said, the latency just goes out of the window. There's no real meaningful application. So there's impact on latency, there's impact on privacy. So the biggest sort of challenge, I think, for designers, for product designers, is to really architect the system in such a way that you're able to trade off what happens on the cloud and what happens at the edge. And bunch of trade-offs, right? How much compute, how much memory, how much power, and how much bandwidth do you have available? So I think that's really the balancing act that we as designers need to keep in mind when we're designing some of these TinyML applications. The other, I think, key thing that also becomes more and more important with the proliferation of sensors is the need for sensor fusion at the edge. And again, it goes to the latency point that that Malik was referring to. And so when you're doing sensor fusion, you definitely need a basic amount of compute at the edge. And then it becomes very rapidly clear that you can't live with a simple microcontroller that you did when you were just doing a simple IoT system, right? So you need something that does a little bit more than that, and I think that's perhaps some of the places where NDP 100 or NDP 200 step into the breach. Yeah, I think that's really where I think TinyML is going now.
Well, thank you so much for that, Milind. And I know you mentioned sensor fusion. It's a favorite topic of Naren, I know. We shall probably circle back to it if we have time. Very, very interesting. So my next question is for you, Malik. Sentient is playing such a key role in this TinyML and always-on voice segment. So we'd love to hear more about Sentient's roadmap moving forward, apart from the third award, of course, which we hope that you will get. But we'd love to hear more about your roadmap going forward.
Yeah, thank you again, Bhaskar. So about talking about our products is always fun, especially as responsible for products at Sentient, for me personally. But when we started developing the first generation, we called it the Sentient Core. The first gen was Sentient Core 1. And then we have with the NDP 100, which Dr. Milind was mentioning about the NDP 100, 101, and that family. Is around that technology. So these chips were, they are currently in mass production. We have shipped more than, as I mentioned earlier, about 10 million to date. And, we learned a lot with this first gen neural decision processors. They are fully connected feed-forward neural networks with small, one of the advantages of being, keeping it as first generation and simple was that it was easy to program, get it into the market quickly, and get market adoption. So, so we evolved that now for the Gen 2. So we call it the Sentient Core 2. And we have it's a remarkable new advance over the first gen, and it's almost 25 times more in terms of the tensor throughput of the Sentient Core 1, and it has a diversity of networks which we can run on it, which can be programmed into it. And this NDP 120, NDP 200, as Milind was mentioning, 120 or 200 are the next gen, and the 120 is the one that we just announced. It's built on Sentient Core 2. We added a Hi-Fi DSP on top of it, as well as we have a microcontroller unit, a small MCU in there. But we envision this Sentient Core 2 to be, going beyond voice as well, and that's what we see as our, what we see in our roadmap immediately. And then going beyond that into the next gen, we see Sentient Core, next core after that to enable us to perform true ASR or natural language understanding or speech or full automated speech recognition. And these will accomplish bigger and bigger tasks and still continue to be low power. Our 120, which we just launched, is under a sub-milliwatt. We can do, not just wake word, but do a lot of different commands. We can do far field, echo cancellation, and speaker verification. These are all things that today in the market, you would want, an order of magnitude, maybe even 100 milliwatts of power. We can do it in sub-milliwatt. So that's our roadmap, and I think we are looking forward to our customers adopting the Gen 2, and then beyond that, we will see, how we can move into vision and image with our next gen devices. And sensor fusion is definitely part of our, sensor core, in the sense that it's a concurrent network, so you can run voice as well as you can bring in other kinds of. I will talk, if we have time, we can talk about the other sensors that we can pull in and connect and run neural networks on. Thanks.
Thank you, Malik. Very, very exciting time. Sub-milliwatt power consumption. That's phenomenal. Absolutely phenomenal. In fact, you touched upon a possible feature on your Core 3, your next gen processor, as it were. And actually, it's going to address the next question I'm going to ask you, which is it really going to be possible to process natural language for richer conversation? That's number one. And number two is regional language support. Do you see a big demand for that?
Yeah, I mean, it certainly is possible. I mean, it's being done today, right? Richer conversation, but the question is, can it be done at the edge at a really, significantly low power, low cost, and affordably, and a tiny enough to make it ubiquitous? Today, we are seeing that kind of richer conversation, talking about being hauled back to the cloud to do it. But we at Syntiant, we are implementing some modeling, acoustic models, as well as more task-specific natural language models to run on these devices. At least at this stage, we are more in the exploratory phase. We are experimenting and we are testing it. So on-device AI in the neural decision processors, or NDPs, will quickly determine the intent of the user. That's how we are thinking about it. So it will be specific to task or the use case that the customers want. So in a retail environment or travel. So that is the domain specific, and we can do slot filling for depending on the user request, and then language models can then be added to convert those models into for different languages. But those can tend to be if you want to cover all languages, or those tend to be quite bulky, the language models for these devices today, and we think that those will be the part which will run in the cloud. But we do see dictation, speech to text, text to speech, real-time translation as things that we will be introducing in the next generation, and that's possible. So that's happening. That's what we are working on now. Thank you.
Yeah, thank you, Malik. My next question, actually, I'm going to start out with a statement. We are very excited at Tata Elxsi at this partnership with Syntiant. I think it has tremendous potential. But from your perspective, Malik, what benefits do you think this partnership brings to the competitive edge AI market?
Yeah, I mean, it's really interesting. I mean, when we first started talking last couple, 2019 or last year, really early last year, when we launched these products, we got, obviously when we launched NDP, we had an overwhelming number of customers interested in our products. So when we, number of we pick, we would have to choose how many customers we could, service or support. But when we started looking for a partner to work with, we were looking for someone who had ML and AI experience. But initially, we were looking at it as more for, there's a lot of, as I was mentioning, for AI and ML, we need a lot of data collection, modeling, and design. But data collection was where we thought, we would work with. But then we quickly realized the design and like what Naren was saying, the entire design experience, the VUI, and then Milan's team on the AI side, we discovered a lot more capabilities in Tata Elxsi that we could actually work with much more closely with. So this is one of the reasons why we said, okay, we want to build this as a collaboration and then scale with the size of Tata, that we'll be able to work as a trusted partner that our customers will be then able to trust as well and work with Tata and us. So this is the reason why we feel this is a good partnership. And we, as Milan mentioned earlier, we just announced it in the press. It was I think there was some PR on this recently, but in general, we've been working, very excited. We've been partnering, and we did actually give a problem to Milan's team and early on and said, here's our evaluation kit. Can you pick your own wake word or and commands and train it? And I think very, very quickly, within 3 weeks or so, they were able to, your team was able to quickly bring together and collect the data and train it, which actually performed quite well. So we said, this is definitely the right team to be working with. And also Tata has experience with other devices, smart devices, smart home, wearables, the automotive industry. So that's another area that a lot of customers talk to us about. So all these new verticals are very complementary to Sentient, and we see this as an opportunity to collaborate with Tata Elxsi.
Thank you, Malik. Great synergies, and as you can see, we do way more than data collection. So it's been serendipitous in that sense to discover each other. But I would love to hear from Milan, what he feels about the partnership and how excited we are about it.
Sure. Thanks, Bhaskar, and thanks, Malik. So the way I look at it, right, I think Sentient brings ultra low power, always on voice solutions to the market. It's a platform. But to build a meaningful solution that a customer can use in the market, we need quite a few things on top of that platform to create that sort of work natural. And that's where Tata comes in. So the first thing you need to create a meaningful solution, I think, is domain knowledge. Very, very important to create natural use cases, understand the domain and create natural use cases. And I think that is, the AI Center of Excellence at Tata Elxsi has been looking at, needs of intelligent systems across domains, right? Whether it is automotive, whether it is consumer appliances. I think the team has dealt with challenges in multiple verticals and dealt with situations where there are power constraints, dealt with situations where data is scarce. So a broad variety of challenges I think the team has dealt with, and that way, the experience in working with some of these domains combined with Sentient's platform will allow us to create meaningful solutions. But I really want to go back and say that, to pick on one thing that Malik said, right? I think creating a meaningful AI solution is not just about AI. It's also about a lot of complementary stuff, right? So a voice sensor is by its very nature in a noisy environment. You're not going to be in a soundproof studio. And so a microphone is going to pick up all sorts of noise, right? And how do you deal with those noise? So there's a bunch of things you can do. You can do beamforming, you can do direction of arrival processing, you can try and do things that improve the signal to noise ratio. And unless you do all of that, you're not going to be able to condition the signal well enough before it can be fed to a voice engine. So that is, that sort of capability is very, very important. The other part, I think, is, having a smart way of partitioning between the edge and the cloud. And Malik sort of alluded to this. Language models today can be real beasts, right? If you look at something like a GPT-3 or a Switch C, you're looking at upwards of 70 billion parameters, and there's no way on earth, that anybody is going to be able to fit that onto an edge computer. At the same time, if you put all of that in the cloud, then latency is going to go for a toss. So I think this partitioning between the edge and the cloud, in the presence of these, almost monster-sized language models, is something that is, where a company like Tata comes in terms of helping people plan the separation and live with that variety of mixed use sort of AI applications.
Thanks, Milan. So bridging the gap is pretty much the exciting potential here. It's been a very interesting conversation. I want to move on to the Q&A section. We have a few really interesting questions that have come in, if I may. The first question is from Rajiv, and I'm going to read this out. It says, AI has progressed to the extent that devices understand the user's preferences at all times, especially for limited number of people, such as a family. Therefore, the aim of the UX designer should be to see how to eliminate UI and not complicate it using multi-sensory interaction. What do you think, Naren? Clearly, this one is for you.
Yes, it's a great question, and it's a raging debate in the design circles, at least. I have a very firm opinion about it, and let me give a very simple example so that you understand where I'm coming from, especially when there's a discussion of whether UI should be needed in case of these hyper intelligent devices and environments around us. So let's take a car, and sometimes you want to be in this racing car where you can feel the power, you can feel the thrill when you're using the interface of your accelerator and the steering wheel, and you're able to sort of really enjoy the experience. So here, the interface is something that you really want. Sometimes you want to be in this autonomous driving car where it is taking you to your office and you want to just take a snooze, right? So the person is not a constant thing in the entire experience equation. So sometimes he wants to, if he's cooking, he wants to feel that he's doing certain things by his hand. On the other hand, he wants certain things that the devices understand automatically what he wants. So we should not take the person for granted, and that uncertainty about what a person wants and what kind of experiences he looks for is the real sort of future where there continues to be this nice balance that we're trying to achieve between what a person wants and how much intelligence should the device have. So it's partly how a UI might have to be designed for that.
Right. Thanks, Naren, for that. I have another interesting question. I think we have time to take 2 or 3 more questions. So the next one that's come in, it says, is voice biometric authentication the solution for user privacy and data security on edge devices? Malik, would you like to take that question?
Yeah, as I was saying earlier, access, or even what Naren was saying, user interface. So if you look at voice biometric, there's a lot of various ways you can think of it. One is like speaker verification, right? Like, for example, is this the person who owns this device? So I have a microwave oven. I'm the only one who can tell it what to do, or if I have a TV, or I have Netflix channels, right? Your spouse and your children, everybody has different channels. but just because your voice, you could, it can automatically know that you're the one who wants to watch the TV, and then you can play that, right? That's a sort of speaker verification example. The other ones are, more, like bio, it could also be, you want to false activate less. I was telling you about the challenges of voice. You don't want it to wake up just because somebody else said the wake word, right? So that is imposter rejection. That is another example of it's a version of biometric. It's a kind of biometric. If you want to go beyond that, like speaker identification, it becomes now, I want to unlock the car, door of my car. I don't want, only I need to. So that is a speaker, access control. It needs pretty strong because I don't want anybody random to open my home or my car or my bank account, which is in yet another level of, authentication and biometrics. So there are various ways you can break this up, but all of these come under the speaker, understanding voice and vocal tracks and identifying who's speaking, right? So there's a lot of, and that's all. A lot of it is actually can be done neurally, and AI can effectively do that.
Well, very, very interesting thoughts on that. We will be able to take two quick questions. I'm going to read out the next one that's coming. It says, benchmarking is one of the challenges in TinyML. How are we addressing this? Milan, do you want to take that?
So, maybe Malik, you want to jump in first, and I'll add on to that.
So yeah, we are actually, benchmarking is a very important aspect. In fact, as I was telling you earlier, we are a member, our founding member actually of the ML Commons, and that's ML. It's like a body, or a lot of different companies have joined together to form ML Commons. One of the challenges is, you need performance benchmarks. Otherwise, everybody, without having benchmarks, you will be able, nobody can come up with, these are our, there's no way to differentiate one product versus the other. And there's a lot of confusion in the market, and the customers do not have a way. Today, even for voice, for example, Amazon did a good thing. They actually have a benchmark, and they, you have to pass a certain, a lot of other companies have picked on that and picked that up and said, okay, these are the benchmarks. So the idea is benchmarks are really critical, because that can, and if you have a common body that can come up with these sort of standards to say these are our metrics and these are our performance benchmarks, and then you meet these standards or these benchmarks, so that's actually what motivates the industry and the market and grows the market use cases and the customers. So you can actually then build devices also that meet those benchmarks, and for performance reasons, right? So that's definitely a very critical aspect of machine learning.
I can imagine. Yeah, thanks for that, Malik. We have time to take just one more question, with a very quick answer, of course. So the question is, how is TinyML energy efficient? How does it take care of metadata, privacy by design, etc.? I think they're two different questions, but okay, let's take the first bit, which is, how is TinyML energy efficient?
Yeah, sure. I mean, from a technology perspective, that's how we are building devices, right? How is it energy efficient is, first of all, if you look at a microcontroller or a DSP, which is a Harvard, architecture, what happens is you're fetching the instruction, you're fetching the data, and then you run, compute on that instruction and data, right? Instead of that, if you could pass the data locally, so one of our Sentience architecture is the data and compute are in the same on device. So in the sense that in near data compute is one aspect. The other one is parallel processing. Our machine learning requires, it doesn't require, like we've been used to, CPUs and DSPs, 16, 32-bit and even 64 or 128-bit. On the other hand, a neural compute, 8-bit or even 4-bit, where like what we did in the first generation, or even binary, is more than sufficient to do a very for neural compute. So those are the areas how we are reducing and improving our efficiency.
And absolutely, and sub 1 milliwatt is what you mentioned, sometime like that itself.
Yes.
Kind of,
yeah.
The way. No, thank you so much. I think we absolutely run out of time, but it's been a very, very interesting conversation. Thank you so much for joining. It's been fabulous. We must have another follow-up conversation soon. Thank you so much for joining. Thank you for your time. And thank you, participants and viewers who logged in. We hope to see you soon. Thank you, everybody. Have a great day, Malik. Have a great evening.
Thank you.
Malik.
Thank you. Good night, guys.
Bye-bye. Thank you.
Thank you. Bye-bye. Bye.
Thank you.
Thank you.